Today we are going to study about the periodic table. We are going to study about the modern periodic table. We had many scientists who in the past helped us to prepare the modern periodic table that we are seeing today. The periodic table has made chemistry much easier. Now, the modern periodic table, the elements are arranged according to increasing atomic number, that is proton numbers. Groups. The vertical column in the periodic table are known as groups. There are 18 groups. The elements in a group have similar properties. So you will see the first group that starts over there. In fact, it starts from hydrogen, but hydrogen doesn't have a particular group. It starts from lithium, that is the alkali metal family, followed by the second group, which is known as the alkaline earth metal family. Then we have towards the right hand side the noble gas, and just very close to it we have group 7 or 17, which is known as the halogen group. Now we have periods. The horizontal rows in the periodic table are known as periods. They are 7 periods. So starting from the top, if we count from the top to the bottom, they are 7 periods. The first group in the periodic table is known as alkali metal family, and we have elements like lithium, sodium, potassium, rubidium, cesium, and francium. All the group 1A metals are very reactive. These metals have one electron in their outermost shell, so they readily lose them to form cation with a positive charge. They form alkaline solution when they react with water. They have to be kept under oil to keep air and water away from them. All the alkali metals reacts vigorously with water to give hydrogen gas and metal hydroxide. The reactivity increases as we go down the group. Few examples are given. Sodium reacts vigorously with water to form sodium hydroxide and hydrogen gas. So in the equation 2Na plus 2H2O will give you 2NaOH plus H2. Potassium reacts again vigorously with water to form potassium hydroxide and hydrogen gas. 2K plus 2H2O gives 2KOH plus H2. In the group 1A alkali metal family, as we move from top to bottom, the reactivity will increase. We'll learn about the reactivity and the atomic size or radius and other properties in the second part of this video. Group 2A. Group 2A is known as alkaline earth metal family. The elements in the alkaline earth metal family are beryllium, magnesium, calcium, strontium, barium, and radium. The oxides and hydroxides formed by these metals are strongly alkaline in nature, and the metal oxides of these metals are found in the earth crust. These metals have two electrons in their outermost shell, so they readily lose them to form cation with a 2 plus charge. Magnesium, calcium, strontium, and barium reacts with water to form metal hydroxide and hydrogen gas. One example over here is barium reacts with water to form barium hydroxide and hydrogen gas. Ba plus 2H2O will give you BaOH whole 2 plus hydrogen. Group 7A. They are known as the halogens. The elements in the halogen groups are fluorine, chlorine, bromine, iodine, and astatine. They are the most reactive nonmetals. The halogen have 7 electrons in their valence shell, that is their outermost shell. They all have a valency of 1. They form diatomic molecules. Their reactivity decreases down the group. That means fluorine and chlorine are very reactive, and as we come down the reactivity will decrease. Here remember bromine is in the liquid form. Bromine is the only non-metal which is in liquid state. Chlorine dissolves in water to form acidic solution. Chlorine plus water will give you HCl plus HClO. Group 8A, noble or inert gases. So they are known as noble or inert gases. The elements in group 8A are helium, neon, argon, krypton, xenon, and radon. All of them have 8 electrons in the outermost shell except helium. Helium has 2 electrons in its outermost valence shell. They are very stable. They are the least reactive gases of the periodic table. The gases are colorless, non-flammable, colorless and monoatomic, and odorless. All the noble gases are insoluble in water. Period 4 and the transition metal D block element. In the transition metal, we have elements like scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. So these elements are in the middle of the periodic table, and they are also known as D block element because of D block metal, because the D block is in the last valence, in the last shell. They form compounds with different oxidation state. These are some of the properties of transition metals. So the number one is they form compounds with different oxidation state. They can form compounds with different colors. They are metals and conduct electricity. They have high melting point and boiling point. They also have high density. Periodic table and electron arrangement. Elements in the same group have the same number of outer electrons. Elements in a period have the same number of shells as the period number. You'll see here as an example, sodium electronic configuration is 2, 8 and 1. It is found in group 1A as valence electron is 1 and it belongs to third period as it has 3 shells. So very easily you can, when you look at the electronic configuration of the element, you will be able to trace them out in the periodic table according to the valence electron and according to the number of shell. Another example, calcium electronic configuration is 2882. It is found in group 2A as valence electron, that is the outermost electron is 2 and it belongs to fourth period as it has 4 shells. So by looking at the electronic configuration, we can trace out the element in which part of the periodic table they belong to. Now, when you look at this diagram tells you about some basic properties of what happens in the periodic table. It also gives you an idea of the elements which are gases, which are metals, which are metalloid, which are liquid, and the reactivity of them. So, if you look carefully into the periodic table, you'll see the green colored blocks. These green colored blocks, like elements there, like helium, neon, argon, krypton, xenon, radon, they are the noble gases. Along with them, we have nitrogen, oxygen, fluorine, chlorine, and towards the left side we have hydrogen. All these are gases. So we'll see that they are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 gases in the periodic table. Then we can see the yellow colored elements over there. These are the metals. Though hydrogen, that is mercury, is also a metal, but it is the only metal which is in liquid state. So you will see the red color or the brownish color liquid, that is bromine, that is a non-metal in the halogen family, which is the liquid state, and hydrogen, that is mercury, that is a metal which is liquid state. Then we'll see a purplish, a pinkish type color that is known as a metalloid. They have a little some property of metal, some property of non-metal, like boron, silicon, germanium, arsenic, stibnum, tellurium, polonium, actinium. So these are actually, they are used as semiconductors also, and they are very important elements of the periodic table. Now, if you look at fluorine, fluorine is the most reactive non-metal. And then we have cesium over there. It's the most reactive metal. We'll come to know why they are most reactive or least reactive in the second part of this video. Now, another thing you'll see is the arrow going up, non-metals getting more reactive. So when we talk about the reactivity, we'll see that the reactivity of non-metals becomes like, you'll see when we talk about fluorine, chlorine, bromine, iodine, astatine. As we go from astatine to fluorine, fluorine is the most reactive. So non-metal gets more reactive as we move up from the bottom to the up. That is in case of non-metal. But when we come to the left side in metals, metals get more reactive. So we'll see lithium is less reactive than sodium, or we can say sodium is more reactive than lithium, potassium is more reactive than sodium, and so on. Cesium is the most reactive. So as we come down in the particular, uh, we can say particular group, we'll see metals getting more reactive. Another thing you will see at the bottom, metals getting more reactive. When we move down from the left side of the periodic table to the right side, the metals get more reactive. For example, when we compare sodium and magnesium, sodium is more reactive than magnesium. Similarly, if you look at the top, there's atomic radius getting smaller, less metallic. So as we move from left to right, the atomic radius becomes smaller and smaller, and the elements become less metallic. All this clarification and the reason why they are like that, we'll learn in the second part of the periodic table. I hope you have understood the periodic table, the basic knowledge of the periodic table just now. And if you like my videos, please subscribe for it. And thank you for watching my video.